Hello, 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 everybody, and welcome back. Root Beer here, looking at question number 23 on the 2007 Cayley Math Contest. So let's take a look at question number 23. Hopefully you've given it a try already. What have we got here? In the diagram, ABCD is a rectangle with AB 12 and BC has a side length of 18. Rectangle AEFG is formed by rotating ABCD around A through an angle of 30 degrees. So we take AB and that becomes AE by rotating 30 degrees. So we get an angle of 30 degrees here. And already my alarm bells are ringing. 30 degrees is a very special angle, so is 60 degrees. You get what's called a classic 30, 60, 90 triangle. And this is a sort of triangle that pops up on contests from time to time, and it is one that you should probably know. So the angles in this right angle triangle are 30, 60, 90, and the side lengths have a nice ratio, which is something that you should remember. The shorter side, the one opposite the 30 degrees, is sort of a 1 to root 3, and the hypotenuse is 2. So if I encountered a 30, 60, 90 triangle, and I knew that, one of the sides, the side opposite the 30 degrees was, say, 8, I know automatically the hypotenuse is 16, and the other side is 8 times root 3. Okay, so this can be pretty helpful, and it's a very nice triangle. I suggest if you don't know it, you have it memorized, you pause the video with this knowledge and try and work this question out, because it's great to practice your 30, 60, 90 triangles. Anyways, I haven't finished reading the question, have I? The total area of the shaded regions is closest to. Okay, so it's one of those find the shaded region sort of questions. All right. Anytime we're doing a find the area of the shaded regions or find the length of the whatever, it's best to break these things down into smaller, more manageable geometric shapes. Okay, so one thing we could do is, well, I notice I could drop a right angle here, and I could break this portion of the shaded into this sort of trapezoid, and then we got another trapezoid here, and we could do something similar up here. Okay, and that's one way to do it, is to calculate the total area of the shaded region directly by breaking the shaded region down. Another way is to focus on what we're not including, and that's this sort of white space here. Okay, if I can figure out the area of the white space, well, the shaded region is just the total area of both rectangles. And then what do we not include? We don't include the white area twice. Okay? It's not included in part of the area for AEFG, and it's not included as part of the area for ABCD. So we take it off of both of them. Okay? So that's another plan of attack. The area of the rectangle is very easy to figure out. We have the side lengths. Now, maybe we could tackle this white area here. And all the while, I'm going to try and exploit this 30 degrees. Now, we might get unlucky. This might be one of those questions that has 30 degrees in it, but no 30, 60, 90 triangles. Even though there's going to be tons of right angles because we've got rectangles here. And that's entirely possible, but I'm on the lookout for 30, 60, 90 triangles. I like to use them. They're right-angled, so if I can figure out the legs, I can figure out the area pretty quickly. So let's draw this picture in our notepad and see what we can see. See, start chopping up. Maybe the white area is the way to go. If it's not, that's okay. I did have some trapezoids there, and trapezoids aren't terrible in terms of figuring out the area. They're just not quite as desirable as squares and rectangles and right-angled triangles. So there, that's pretty good. Now I think they called this intersection H. You got A, B, C, D in here, and then it was E, F, and G up here. And we'll make the B actually look like a B for a second. Alright, so what do we know? Well, this is 12, which means this side length, AE, it's the same length, so it's also going to be 12. Now we have 30 degrees here, and it's a rectangle, so I have a full 90 degrees here, and that means what's left over here is 60 degrees. Okay, I'm just going to shade some things in so I know exactly what area I'm talking about. I want to talk about this white area right here. Okay? Well, what am I going to do? I see that 60 degrees. I think, gee, wouldn't it be nice if I had a 30, 60, 90 triangle? So I'm going to go from E, drop that right down to AD, drop it so it's a right angle. And now, looky here, I've got A, E, I guess we could call this guy I if we really wanted to, but I've got 60, I've got 90, the other one's going to have to be 30. And hey, I know the hypotenuse is 12. So the hypotenuse is 12, that means that half of 12, 6, is the side length opposite the 30. Alright, remember, 2 to 1 to root 3. And that also tells me that this over here is 6 root 3. Okay, so I've got a triangle, but then what have we got left over? Well, we do have a trapezoid here. IEHD is a trapezoid. So we could probably work with that. If I knew the height and I knew this length right here, we could certainly try something like that. Or maybe there's more we can do to break this down. I'm going to move this 6 root 3 inside the triangle, just so I have things a bit more clear. What else could I do? Well, I know all of AD is 18, but I know AI is 6. That leaves 12 left over here. And what else? Well, it's a rectangle, so I guess I have a full 90 degrees here. And with the 30 taken for AI, I guess we have another 60 degrees here. So what if, from H to EI, we drop another right angle triangle? Now here we'll have a rectangle, because we got 90 degree here, 90 degree here, and a 90 degree here, and that forces a 90 degree at H. And now I've got a 60, 90, 30, so a 30, 60, 90 triangle again. And now this time I don't know the hypotenuse, but I do know a side length of 12. Okay, so 12 is opposite the 60. So we're going to have 12 over root 3 down here. And twice that, so 24 over root 3 is going to be EH. All right, so what have we got? Let's just draw our white area again a little clearer. HD, I guess we called him I. We might call that in here J. A, E. So I've got two right-angled triangles, and I know their various lengths. 6 and 6 root 3 here. And I've got this rectangle here. Now, if I knew the height of the rectangle, I think we'd be all set. What is the height of the rectangle? Well, this is just going to be the 6 root 3 that is all of EI minus the 12 over root 3 that is all of EJ. But I can work that out. 12 is 3, oops, it should be a minus sign, is 3 times 4. But of course, 3 is just root 3 squared. So when I divide 3 by root 3, I just get root 3. So 6 root 3 minus 4 root 3, 2 root 3. And so now the white area is triangle AEI plus IDHJ plus EJH. Let's work those out. So AIE is 6 times 6 root 3 all over 2. IDHJ is 12 times 2 root 3. That's the height IJ there. And EJH, that's another triangle, so it's 1/2 base, 12 over root 3, times height, 12. Okay. So 6 times 6, 36 divided by 2 is 18 root 3. We get 24 root 3 here. And once again, I'm going to convert my 12 root 3 into 4 root 3, which I already did over here. And so half of 4 is 2, so we get 2 times 12, another 24 root 3. And 24 plus 24 is 48, plus 18, well, plus 10 is 58, plus another 8 is 66 root 3. Okay? So the shaded area was 66 root 3. And now, what was our plan of attack? Well, I mentioned earlier the shaded region is twice the rectangles minus twice the white area, the non-shaded area. Well, the rectangles are 12 by 18, and now we know the white area is 66 root 3. So 2 times 12 is 24, times 18. So 12 has a factor of 3, 18 has 2 factors of 3, so that's 27. 1 factor of 2, 2 factors of 2, 1 factor of 2, so that's 16 times 27. I can't do that in my head. 27 times 8 is 216, times another 2 is 432. Okay, I could do it. Had to do a little bit by hand. Minus 132 root 3. Now, if we check our possible answers, we will not find this at all, because if we'd had a careful glance before we flip to our notepad, we would notice their answers are all decimal, and our answers are closest to. So, I'm going to grab my handy-dandy calculator. Okay, so we had 432 minus 132 times root 3 here, and we'll get 203.36. And if we go back and look at our possible answers, we'll see that we have, I guess we rounded up, and that's going to be an answer of C, 203.4. So that's going to be my final answer. So this is approximately 203.369, but I'm going to round that up to 203.4, and that is an answer of C. Okay? And that was question number 23. Up next will be question number 24. I will see you for that in the next video.